virtual faculty development program and emerging research trends in computing technologies. May now request Dr. T. Kumanan, Professor, Department of Computer Science and Engineering, Dr. NGR Educational and Research Institute. Please, sir.
Thank you, ma'am. Is it audible?
Yes, sir. Yes, sir.
Shall we start?
Yes, sir.
Okay. It's a very good afternoon to one and all present over here. This is a fine evening to all of you because of the great resource personalities with us. So past 4 days they were giving the emerging research trend in computer technology from various personalities. So today is the 5th day given the given the talk to Mr. Sudharsan Srinivasan. So before that, I welcome the Dr. Sudharsan Srinivasan, professors, faculty members, and participants from various universities and colleges. So, Mr. Sudharsan, it's a great pleasure to invite and take a privilege to introduce the Mr. Sudharsan Srinivasan. He is a retired software professional leader from storage domain. He completed his BE Computer Science in Dr. MGR Engineering College, University of Madras. He has a skill in software project management, software engineer, software design, testing, software development, device drives, agile methodology, process management, storage plan, projects, planning, integration, requirement analysis. These are the special skill for the Mr. Sudharsan Srinivasan. Before that, he started his work as a software engineer in Siemens Public Communication Limited, Bangalore, as a design development of Samsung, a centralized equipment management system, design development of accessing integrator, a large-scale client-server management system for access network elements, responsibility development of framework development component of AI, lead a team of engineers in developing operational status management, database management systems. He coordinated the product of integration effort with Siemens at German. Later, he worked as a software engineer in Erection, USA. He worked as a group of project management organization, HCL, for 9 years. He worked in NetApp as an engineering manager and engineering program manager. Finally, he worked in SanDisk Western Digital Company for more than 6 years as a director and system design verification and senior manager for testing development. Mr. Sudharsan is a fantastic person to work with in technical and add a great value to any discussion, and is very mature and balanced in his thoughts. He has excellent multitasking skills and he has leveraged them well by taking and development, QA, and programming leadership role concurrently for a set of related products. Sudharsan is a detail orientation manager who keeps close eyes on program milestones and inspire the engineering team and program stakeholders to achieve them. He is constant thinker and he is like to explore efficient way to solve the legacy and new business problems. Mr. Sudharsan is an excellent program and project manager with a very sound technical background. He is very meticulous in planning, execution, and monitoring. He is always work towards the success of the program and thinking from customer shoe. This attitude has earned the heart of several customers. He is also a very good people manager who take care of the team. Overall, Sudharsan is a highly capable manager and add a great value to team and business. So with these notes, I welcome the Mr. Sudharsan to deliver his lecture. Sir, please welcome, sir.
Thanks, Dr. Kumanan, for the introduction. I didn't know that you had so much of information
Thank you,
about
sir. Thank
myself. So let me start without wasting much time. This is the
Yes,
first
sir.
time I'm on Zoom, so I'll share the screen. Let me know if you're able to see the screen. Revati, can you confirm if the screen is visible?
Yes, it's visible.
It's visible, sir.
Yes, sir.
Okay, thank you. So, when I was asked to talk about, R&D, research and development, I was thinking about a topic, and there's a lot of myth about the R&D, even when I came out of college, right? So, we have a lot of myth in the sense that research and development is all science projects or only scientists will work on. So I thought, let me clear some air based on my understanding that I have worked on this industry, in the storage industry or in the software industry for more than 27 years. So that's why I picked the topic of understanding the why. Why, when we understand why an R&D is required, we will understand what is R&D, and we'll be able to bring that thought process in all of us, starting with the faculties, moving towards the engineers who are coming out. So that is the reason for understanding the why. So I'll give a quick brief about myself. I think already Dr. Kumanan gave enough introduction about myself, so I will rush through. So I'm an proud alumni of MGR Engineering College, passed out in 1995, finished my computer science engineering, and with the same thought of what is R&D, or not knowing what I will land up in. Fortunately, I have all the 27 years I've worked, though I said mostly in R&D, I've worked only in R&D. All the projects that I were involved are all R&D projects. So we'll look into, I'll give some practical examples to see what is R&D, and I will probably talk more about innovation, right? So that is very key when we talk about R&D. So I've worked in 3 different domains over a period of 27 years, though most of the last 15 plus years has been on storage domain. I've also worked on telecom and briefly in banking domain for 3-4 years. Already we spoke about my expertise is, I'm strong in management skills, meaning understanding the business, understanding the customer, and how these customer requirements we return into a product, and why we are doing a product, and building a strong team, in making them understand what they are doing, and once we make them understand what we are doing and why we are doing the R&D projects or any project, be it development or enhancement, will become a lot more simple. So I recently took a retirement from my corporate world. So currently I'm chasing my other childhood passions and dream. And of course, when I was asked to give a session, I was all the more happy because I want to see how I can share the knowledge that I've gained in the industry back to the education system. And you are the great leaders in terms of bringing the next set of engineers out from the college. So I'm not a slide deck oriented guy. So if you have some questions, please do pop up. I'll try to answer all of them. There's a Q&A, I am sure, where you can drop by, and I will try to answer them in the end. If there is something that you're not understanding that you need to answer immediately, please raise a hand, and the moderator will help me to answer. And if I don't know an answer, I will definitely get back after the session doing my own R&D. So with that, let me start with this question of why do you think we have to spend in R&D? I'll also tell what are the challenges and really whether R&D is required. Okay, so R&D stands for research and development. You all know. This is something, research and development typically involves something working on something that is unknown. Okay, when I say unknown, you may not be solving a problem for today or for the immediate need. So why R&D? Let me talk about some of the cons. To even think why we should be spending in R&D. So if you're not aware, the R&D projects typically don't yield revenue immediately. So I'm talking about revenue. I know this is not something in college we talk about, but when we talk about a company, a business that is doing some business, revenue is very important. So take any company that you might know, for example, HCL Technologies or Tata's concerns. They are doing projects. When they make a product, they have to generate money so that they can continue to do the business. So the R&D projects are not going to give revenue immediately. So that could be one of the questions why we should do R&D, right? Next is the success ratio of a new project, of a new solution, is about roughly 1 in 10. Don't take my quote and go and do a Google search. For that matter, any of that I'm talking here may not be in Google because this is based on my own experience. Typically, 1 in 10 R&D projects will see the light, its end of light, and be successful. So it may not, as I said, it may not solve today's problem. Let's say we are working on a banking project, and you want to take money out, or put money in. I'm not developing a project for that because there's already a solution for that. And more importantly, R&D projects might be challenging. I'm not from an electronics background, but I'm a computer science guy, so I always love to see what I do. I write a program, it provides an output. But if you're from electronics, or first time when I was as a child, they said electricity is flow of electrons. I can't see the flow of electron. So which means if I can't see, it's going to be challenging. So R&D projects are like that, because where you have a concept or you have some requirement, you're working on something that's going to solve as a problem for future. So it will be challenging because you don't have a solution immediately, or you may not see the solution immediately. Then why spend? So one of the key, let me talk from a business perspective, then from the customer perspective. The main reason to spend in R&D projects is their revenue multipliers. What I mean by revenues, you might see the correlation to the first bullet, where I'm saying it's not generating revenue immediately, but I'm working on a solution that's going to be a solution for a future. So which means I will be the first one to provide such solution. I'll be provide a different solution, or a solution that is path-breaking. So which means the revenue that I'm going to generate is going to be multiple fold than continuously doing the same thing, where the revenue, the margin that I get, the gross margin I get, is not that high than an R&D project, which will yield a higher revenue. Okay, so it's a revenue multiplier, which means as a company, I should have, if I am a product company, I should spend some money in what is yielding me revenue for the next 1 or 2 years, and also spend some money on doing these R&D projects so that my future is not bleak. I continue to have a future. So I cannot just have a company that survives for 5 years and I don't think about what is going to happen after 5 years, after 10 years. So I should spend something on these R&D projects, which I'm willing to, with a expectation that it can yield at least 10 times. Right? So that's the reason we need an R&D project from a business perspective. From a customer perspective, I have some examples in the next slide. These are the problems that is not seen by the customer today, but it's going to become a problem in the future. Could be 6 months, it could be 5 years, or it could be 2 years. But we are talking about problems that are going to potentially happen and want to have a solution when it happens. Okay. And of course, R&D projects are challenging for engineer. I'm still an engineer in my DNA. For an engineer like me, a challenging project is what is going to keep me going. Right. So for R&D projects are going to be challenging, but that's what keeps my passion going on, and try to keep investing. So this is the reason why spend in R&D. So we need to spend. Business has to spend in R&D so that they can be in the business even after 5 years, and it's going to be a revenue multiplier, and it is going to solve a problem for customers in the future. So let me talk about some practical example. How many of you have heard about a programming language called Smalltalk? Maybe someone raising hands or something will help me so that I'll have some interactive session. Have you heard about small talk? Anyone has heard about small talk? Anybody raising hands saying that I've heard? Okay. Oh, good. So do we know why a small talk language is required? It's one of the 5G language, right? We already have C++, so many. Anybody knows why we need another language called small talk and where it is predominantly used? I'll answer anyhow. So small talk is predominantly used in banking domain, if you're not aware. Of course, it's used in telecom also, but to a minimal extent. So I'm sure many of you might know about the data types and the programming language. So typically we have a data type called integer or float. And let's say you go to a banking, and especially if you're talking about corporate banking, not retail banking. Corporate banking, they deal in multiple crores, right? So let's say an interest rate that a fundraiser is providing is at 1/3. Let's say he says, I give multiple crores of currency of dollars, and the rate of interest is 1/3 of what I'm giving. So typically, if you take any of the programming language, 1/3, if you have to put in float, at some point in time, it will go to a 10th position or plus E, whatever we put, right? So 1/3 will be 0.3333, and then somewhere it will become 0.3334. When you apply to multiple crores, you might lose some dollars, good amount of dollars when you're handling a crore. Smalltalk is the only language I've seen where 1/3 is maintained as 1/3. So it's an object. 1/3 is an object. So if you multiply few crores into 1/3, the value that you get, and if you're using another programming language where 1/3 is represented as 0.333, to some precision, it will cut off and you will lose dollars. So just as an example, I'm giving. So it's a Smalltalk is a wonderful language where everything is maintained as objects. It has classes, and even classes has meta classes. So someone has invested in developing a language like Smalltalk where everything is an object. 1 is an object, 3 is an object. So 1/3 is maintained as 1/3, and I can't lose dollars. So that's why if you see, especially in the corporate banking sector, Smalltalk is widely used even now, though many don't know or many are not knowing about Smalltalk or using Smalltalk. That is the reason why we need Smalltalk. So we all are talking about 5G. Many of you will know 5G. We all heard about, even Modi ji inaugurated the 5G. But why 5G? Why do we really want to go to 5G? The 5G's requirement is driven by all of us. The mobile world, we were watching, we were doing texting, then we were doing WhatsApp, then we were sending some GIFs, JPGs. And now we are watching movies and, a lot of live streaming in mobile. So the rate at which the data has to be transferred has to be taught differently. So that's where the TDMA came initially. If you're in the telecom background, time division multiple access, then came the CDMA, code division multiple access. It didn't kick off much well in India though. But then these are the ways, why people started looking into new ways of, communicating, new ways of, making the cells talk better. So that's why the 5G has come in now. So it's driven by the customer. Once again, I would like to stress upon the need that any R&D that we are doing is driven by customers. So 5G came in because of the customer needs, right? So the entire world is moving towards 5G. I don't know if you have heard about edge computing. It's something that is happening as we speak. Anybody has heard about edge computing? Anybody can raise the hand to say, that's good, that's good. Can anybody tell why edge computing came in? Any examples? Is there a way, who's the moderator, Revati or Geeta, for someone to type or anything to say why edge computing is required? I just want to keep it open so that people can think also why we need, because the why part is the key for you as faculty, so that you can inculcate that why part into the team. Okay, that's fine. The edge computing came especially with the invent of, you might have heard about talking cars, right? So now this is especially more so happening in US, where a car is on the freeway. I mean, what we call highway here is called freeway there. Let's say you are on the side roads. The car is running and then it hits into a traffic jam. So this car can communicate to the cars that are coming behind it, in a chain of reaction, saying that there's a traffic jam. How the Google Maps is doing it now, the cars can start talking without the need for going to Google Map, and Google Map needs some time to refresh that there is a traffic jam or there's a pothole, right? The Google Maps doesn't dynamically update a construction work. Let's say something is happening and someone is digging the hole, digging the road, and it's not immediately known in Google Maps. So this cars can start communicating. So what this means is, if the car has to communicate, of course they are communicating through the telecom network that they have, and it will send data back to the data center. The data is going to the data center. It will go get processed. The Google Maps, why it is slow, is it will go to the whatever the data center that may be. Let's say I'm driving in Chennai, and then let's say in Anna Nagar, and then there's a traffic jam. And there may be a data center that is probably sitting in Mumbai, okay, not in Chennai. Maybe Google is having in one centralized location. This data has to travel, and then go through multiple hops, go to the Mumbai data center, and then it will communicate back. All this will take time. So that's why you might see Google Maps taking more time. But if this has to happen more faster, the edge computing, what we know about edge computing is the equipments that are on the edge. So let's say the data that is from the car has to be processed, and the data has to be sent back to the network, not going to the centralized location, but to a local hub. So the local hub need not have too much of processing power, but it needs some compute power, and it needs some storage power. The reason I'm talking is that's why I'm giving a logical reasoning for storage. All these leads to storage. 5G, you're talking about faster mode of transmitting data. Edge computing, we are talking about faster mode of sending data to a local hub or on the edge, or on the, you may even get processing power in the car itself in future. So you need all these to be sent to a local hub, and then the car can communicate to the next car. So that is the edge computing, right? So you don't go to a centralized location, send all the data to a far enough place and come back. It takes a lot of time. So the edge computing happens on the edge, which means on a local site. For example, and just take it like a local site. And to happen, for all these happen, if you see, there's a huge amount of data, huge amount of storage required. So previously, what is happening in a centralized location, is going to happen in a localized location, which means even at the localized location, you need storage, because the data cannot be simply processed on the fly. So it has to be stored and then processed. So these are some of the examples of R&D. The why edge computing, if you see why it was not there all these years, why we're sending to data to the centralized location, is because the human needs, customer needs are increasing, are changing. How many of you are so frustrated to take a Google map, you drive through, and then you figure out that road is end. There's no road. And probably because Google map was updated based on someone who drove on that road a day back or 2 days before. And after that, something happened to the road and there is no data. But there may be people who have been driving, but the data was not given because maybe the individual was not using the Google Maps. But if the car or the vehicle has the intelligence, then without a human intervention, these data will get captured, and then it will be processed in the localized location and then moved to the data center. So this is once again R&D. It might look very simple. Why is this really an R&D? But it is required because what was being done in centralized location needs to be done in a localized location. So all these is what was making storage to evolve, or the requirements kept on changing, and that's how storage is one of the booming market. and so much of storage players are there. So we will look into how storage evolved. So I'm talking, this is more of a protocol. SATA, serial ATA, I forgot about the abbreviation, SAS. SAS is SCSI based, and then it moved on to NVMe. I'll talk in detail in the next slides what these mean and why we went from SATA to SAS to NVMe. And of course, when we talk about removable disks, we had SD, micro SD, USBs, and on top of all of that is HDD stands for hard disk drive, and SSD stands for solid state devices. So once again, moving from HDD to, I will talk more on the HDD and SSD. Of course, I've been working on SSDs for the last 6-7 years, so my knowledge on SSD might be a little more than HD or the other USBs and micro SDs. But they all play the same game. So HDD was the one that was there, has been there for more than 30-40 years since the time we know, and in a very robust system, and it was sufficing the needs of the customer at that time. How much ever data we want to store, we can increase the storage size by adding more hard disk drives, and all that was good. But the rate at which data is being accessed, you might have seen all the examples I was talking till now. The rate at which we are accessing data has changed. Okay, so think about this. Let's say you go to an ATM, you withdraw cash, right? And that's a processing. Of course, the data is getting communicated to the server, the bank server, and then it has to check what is your balance. It has to send the data back, right? And then say, okay, credited, debited, whatever transaction you are doing. The rate at which HDD, hard disk drive, can read and write, especially the read, is not comparable with SSD. So when you take the entire country and the servers is not local, it's going to be for each city there will be server. Let's take an example of one of the banks, let's say SBI, and there will be so much of ATM transaction happening on any given day, any given hour or minute. So if the HDDs are still being in use, imagine, will you be happy if, let's say, I swipe the card and it takes 5 minutes to get to the next screen, another 5 minutes to tell what is your balance, another 5 minutes to say, okay, you're withdrawn, and then overall one transaction takes 15 minutes, let's say, for a hypothetical discussion. None of us will be happy, right? So things have to happen faster. So if things has to happen faster, not just the computing power, not just the network speed, what matters is also the rate at which you are accessing the data from the storage media do matter. So that's how it's the customer who drives these R&D. That's how the SSD came, sometime in 1980s, I believe, 70s, 80s is when it started. The SSDs, the solid state devices. SATA was the one, SATA-based SSDs were the one which started initially. But the primary reason was the HDDs were not providing the performance at the rate at which the customers want to read or write data. So with that, I'll give a pass. Let me have a bottle of water, and then I'll continue. Give me a break. So any questions so far? Anything came in the question window? Who's the moderator here? Is it Revati or Geeta? Is there any questions for me to answer now? Till now? Dr. Kumaran, do you know?
Participants, if you're having any doubts, please post your questions in the chat box. Participants, if you're having any questions, please post the questions in the chat box.
Thanks, Dr.
You can continue, sir.
Sure, thanks. Okay. So let me talk about HDD versus SSD. And as I talk about it, I will talk about some of the practical examples I have seen in my experience, which I believe are some of the innovations or the R&D that are coming in. I think I saw a couple of people raising hand. Any question there? Okay, I'll continue. So if there is any question, Dr. Sonia, please interrupt me. Okay, so
Sure, sir.
HDD, hard disk drives, or let me put SSDs were preferred now for two reasons. One, performance, and another, power. I'll tell you why. So hard disk drives, you can, IOPS stands for IO per second. A read is an IO, a write is an IO. So typically a performance of a drive is measured by, IOPS, and in some cases specifically the read performance and the write performance. So if I look into hard disk drive, you can do 500 IO per second. So which means you can do 500 writes and reads in terms of bytes per second. So 500 bytes per second, or read 500 bytes per second. Typically read will be more, write will be a little slower because of the magnetic movements and in case of HDD, same as the SSDs. So if I'm writing only 500 bytes per second, I was giving an example, right, of a bank transaction. Think of, so many millions of users, especially in India, doing this banking transaction. And if I am writing at that speed into my storage, because everything has to be stored somewhere, right, even if you have a processing part, it cannot suffice the need, right? So I need a faster media where I can write and especially read the data back. So that's where the SSDs, the solid state device, is nothing but a bunch of flash, the NAND, mostly the NAND, more often NAND flashes because it's cheaper than the NOR flashes. The NAND flashes on which you can read or write. It gives easily to up to 7K IOPS. There are research going on still to increase the IOPS further, and there are some firmware upgrades that are happening to make it faster, specifically focusing on read versus write and stuff like that. We will talk about one such enhancement or solution that is currently in progress in an R&D phase. So we are talking about multiple fold. I don't have the ratio. So 500 IOPS versus 7K IOPS for in SSD, and SSD also uses a lot less power compared to HDD. Obviously, HDD has a lot of moving parts, and SSDs, the NAND flash, have their own. They don't need it separately power to maintain the state. So even when you have switched off the system, the host is typically this. When I use host can be the laptop system or the system to which the disk is attached. That's what we call typically host in the industry. And it doesn't require that much power. Of course, HDD has a very good cost advantage. Maybe 5 to 6 times more compared to HDD. The SSDs are priced higher. I think 1 TB hard disk I have never bought because we always get SSDs from my own company. So I think one hard disk drive, if it 1 terabyte, if it costs $100, maybe the 1 terabyte SSD might cost $2,000. That's the range we are talking about. Another drawback in SSD is the SSD's life. I mean, the durability, the data loss, what we call, the data that we write can get lost as the life of the SSD goes on. We will see why once again in the next slide. So overall, if we look into cost versus performance, we need to decide which one to use for what kind of purposes. So if you are looking for some faster access of data, obviously SSD is a choice. There are different solutions that we once again worked on. So this is only an SSD. So there are once again the RAID systems that you would have heard about, or the caching algorithms that you would have heard about. In storage industry, SSDs, for example, are used as a cache. So let's say I am writing data. Only for simplicity, I keep talking about banks because you can easily correlate, or even for the Google Maps, you can talk, or anything that you see, right? Or your storage that your WhatsApp that you see, messages that are coming in. Those are all saved in a common storage. So anything that you are accessing more frequently, there are algorithms, that are written on the storage arrays. A storage array is nothing but a bunch of storage medias. Could be a bunch of hard disks, or a bunch of SSDs that you put in, and let's say 500 1 TB SSDs or 1 TB hard disk drives, I can put into one box, and then I can say I have a 500 TB storage array. So there are algorithms. These are the algorithms that are part of the R&D effort that are developed where we have smart way of caching. So the cache SSDs are used as cache because we can easily retrieve fast. We can retrieve the data fast. So there are algorithms like read ahead. So if we know the pattern of reading from a particular application, this particular system can have intelligence in deciding which are all the blocks of data that are being frequently used, or when this block is being read, typically the following blocks are being read. So there will be some chaining that will be done, and that will be retrieved from the hard disk and kept in a cache, which is an SSD. Okay, so or when you do a write, right? Typically, when you do a write, the write has to be faster, and writing to a hard disk or to a secondary media will take time. So in that case, also the SSDs will be used as cache, so that you will write it to the SSD, and then you will get a response immediately saying that the the data is written, and then it will flush to the secondary media later. Typically, in the consumer electronics, let's say you use a CPU or systems that we use at home, which doesn't require too much of fast access. That's when HDD is used. In all of the enterprise solutions, most of the enterprise solutions, SSDs are used. When I say enterprise, I'm sure many of you would have heard about the Amazon Cloud, right? Amazon Cloud Storage, where you can put that in the cloud and you want to get the data back. So typically the front end part of it, when you want to write immediately, there will be SSD that are maintained. Of course, they may push if the data is not used very frequently. Let's say you have your emails, right? You might have a Gmail account or a Hotmail, and you may have thousands of emails that you don't never access. Periodically, there will be an algorithm. Once again, that's the R&D. So we need to make the SSDs are costlier. So which means I cannot, as an Amazon, if I were an Amazon, keeping all that data in SSDs is going to be very costly, because I cannot multitude my storage where the SSD is very pricey. So what I will do is I will do an R&D to see how I can optimize my storage cost so that I can still meet the customers and provide so much of storage at a lower cost, because cost per GB has to be low, and still make a revenue. Then that's when the new thoughts come in, where there are some algorithms that were written, though I was not involved, but there were algorithms that are written, which will be in Amazon also, I'm sure, where they will move less frequently used data to a secondary media, a slower media, which is not that costly, and keep only the most frequently accessed and the write in the costlier SSDs media. So this is once again an R&D project where there will be a data analysis being done and build a smart algorithm which will look into the data, which will look into the write pattern, which will look into the read pattern over a period of time, and will also have some counters to decide. I'm saying this is how it could be implemented, not necessarily that's how implemented in such companies. And look into define an algorithm, develop a code which brings that smartness to ensure the less frequently used data is moved to a lower cost and less slower media and less costly media, and keep the frequently accessed and write only in SSDs. So I hope I touched a bit on why R&D and what is a kind of an R&D. Developing algorithm is an R&D. Developing a new type of hardware is an R&D, and moving to a new protocol. These are all R&Ds. That is what is R&D, and R&D doesn't mean it has to be always a science project. Let me re-insist. And I will talk about innovation when I go a little more deeper into specific projects. Okay, so we spoke about SATA, SAS, and NVMe. SATA is serial advanced technology, and it has faster data transfer compared to PATA. PATA is not much in use. Many of you have not even heard about it. One advantage of SATA is it's hard swappable because it's a half duplex. So one directional at one time, you can either read or you can write. You can't do both. And it's a lot more cheaper than SAS and NVMe drives. But the speed at which you can write is not as high as you would typically want in SSDs, because it uses only one channel, which means you can at a time write only once. So if you see, was there a question? Okay, so if you see sometimes in late 80s and early 90s itself, the processing speed of the computers increased, and we were talking about multi-threading, multi-processing, and came the multi-cores, right? So dual core, quadra core. I think now there are 8 cores and all. So which means the computer became too fast and was able to send data parallelly as you have multi-core. Okay, so when the multi-core came, that's when the SATA became a challenge, because it is half duplex, unidirectional. It has only one channel. So even though the host, which has multiple cores, let's say even if it has 2 core, dual core, is able to send data, more faster and in parallel, which SATA device cannot handle. Of course, you can say I can connect 2 SATA to the hard disks into the same system and then suffice the dual cores system. That's at a quick and dirty solution. But then it is not sufficing the need when the host, dual core and host has multiple applications. Each of the application can work independently in sending data, which means you need, while the computing power, the host improved on their mode of communication, the storage was not able to handle it. So that's where the SAS came in, serial attached, that's SCSI, which is a point-to-point protocol, which means it can talk to the drive faster. And, of course, in order to talk, there is a HBA, host bus adapter, that is required. And once again, I will not talk too much about SAS because it's not going to help us. I'm not going to talk in detail also what is SATA, SAS, and NVMe. But take that SATA has a unidirectional half duplex, only one channel. So which means when I have multiple cores, it's going to become a choking point. SAS is the next protocol which help to provide a point-to-point communication. So which means the communication between the host and the device improved, and you need a HBA, host bus adapter, because that is the one which will convert the host commands, the SAS commands, into the commands that the media, the storage, can understand. So the host bus adapter is required and to communicate when it's a SAS. And HBA became a limitation because the rate at which the HBA can translate and talk to the media is the rate at which the data can go, not at the rate at which host can talk directly. So this is the reason why the NVMe came. Okay, the NVMe uses the PCIe slot that's available on the host. When I say host, the system, right? The PCIe slots that are available on the system is where the NVMe drive will be connected. And this NVMe protocol is able to talk to this. Using the NVMe protocol, you can talk to the device directly without a need for any adapters. So which means I can plug in an NVMe drive into a PCIe slot, and the host is talking to through PCIe directly. So I'm cutting down all other channels, which can become a bottleneck in the communication of data, right? The data that I'm writing. That is the reason we moved from SATA to SAS to NVMe. As I said, SATA is single channel. SAS broke that by providing a point-to-point communication, but then it was limited by HBAs because HBAs can only translate so much. And NVMe, now you have NVMe where you have 32 channels, which means, and I can, if I have more PCIe slots, I can put so many drives in parallel. So I can use all the 32 channels to talk to the drive, which means if I have multi-core, if the data is being pumped by the host, the NVMe drive will be able to accept all of them in parallel because the PCIe slots are the one which is used and I have multiple channels to communicate. Let me know if this gives you a perspective of why R&D, right? Not that I developed a SATA or I developed SAS or I developed NVMe. The standards came. The standards were forced to think about, do some research on going towards NVMe or finding a solution where I can cut down the intermediate adapters and use the full 32 channels that is available for communication, so that the rate at which host can write, the storage can match. So that's the kind of that's what we mean by R&D. Okay? And I'll talk a little bit more in the lower level, because not all of us will be involved in this industry standard protocol development. Of course, with all these, with the movement from SATA to NVMe, the speed improved, the size, the size of the drives increased, reliability, scalability, and security also increased, because the NVMe protocol also has a lot of security standards, so that if someone cannot simply crack into the data that is being written, you can encrypt the data that is being written. Let's not talk about all this, but each of these: speed, size, reliability, scalability, security, the banking application or any data center, the need kind of security they need. All these are the ones which are driving. These are customer needs that are driving the industry to find new solutions. How security can be enabled, how we can do data that goes over the wire is encrypted, the data that is getting written into the storage is encrypted. So these are the reasons why we are moving to new protocols, and why there is a need for security and things like that. Okay, so I'll go into the SSD little bit. I'll give a little bit background on how SSD works, and then I will talk about some of the validation. I was working though I started as a developer, the last 5-6 years, I was mostly working on validation of the firmware, and I was heading the validation organization as well. I will talk about some of the innovation thought processes, which we can see as an R&D, and this is what we are expecting as the industry is expecting from the students or the engineers who are coming out of the college to have this innovation thought process. So give me a second. So if you see in HDD, hard disk drive, data is written using spindles. You have I forgot. So you have the disk and you have the spindle that will go and write. So there's a lot of mechanical parts. SSDs does not involve any of those. SSDs is basically storing data in the NAND flash or NOR flash, and typically whatever we write is zeros and ones. You all are aware, it's binary. Zero is basically a presence of signal, right? Electrical signal being there in that cell means it's a zero, and absence of a signal means it's a one. So that's how it is typically programmed. So whenever we write a bit, if you're writing zero, it means we are fusing a signal, and one means we are diffusing the signal. That's how, remember this concept, because this comes handy in understanding many of the other challenges that happens in SSD and how it is being written. So typically, so when we write, which means I'm fusing, I'm fusing, and one means diffusing. So write involves erasing. So which means if I have to write a one, right, I have to erase that, or the values will be there already, so I have to erase, and then only I have to write. So that's called a program cycle. So a write typically requires read, modify, write. Writes are the storage, the NAND, if you see logically how it is broken into blocks and pages. Writes typically happens in terms of pages, but a bunch of pages forms a block, while the erase will have to be done only at a block. I'll tell you why also. So as you see, there is the signals being written every time we erase. It's actually we are writing something irrespective of whatever it is. Whether we are writing zeros or one, we are erasing. So what happens is over a period of time, the signal will become weak. So let's say if I'm writing a zero, which means a signal is being written. And these are all only signals, which means if I keep writing to the same place, the signals can be lost. So slowly the signal value can go down. So a zero can be seen by the controller as a one. Okay. So another thing is, remember I told writes are done at a page level, while the erase can happen only at a block level. So the reason why the erase is not done at a page is smallest, block is the next level. So remember that block is and 8 pages can make one block. So when I write at a page level, I will erase only at a block level. Now I will explain why. So if I erase, frequently if I keep doing an erase, which is called the program erase, frequently if I keep erasing the a page, right? Though I write a page and then I modify a page, which means I need to erase that page and then write a different page, right? Either on the same place or in a different place. So if I keep writing and erasing and keep writing and erasing, after all, it's a signal. So the signal, I'm not an electronics guy, but the amount of signal that it can maintain in that NAND flash will go down. Okay. So whenever I erase, I don't want to erase at a page level, because if I keep erasing pages, the pages will become of waste. So what I will do is, whenever there's a erase required, I will accumulate the pages and erase a block at one time. So which means the number of times I erase is reduced. So when I need to erase an entire block, it will not be that frequent, while we need to erase a page will be very frequent. So that is the reason we don't erase a page. So what we will do is, typically when we have to modify at a page level, let's say I want to change a value that was already written on a page, the page will not be erased. So it will be marked dirty. So instead, when I say marked dirty, it will be kept like, it's not in use anymore. And then I read the remaining pages. Let's say there were 8 pages that constituted your one file. So I will read the 7 pages and write to another place. And this one page alone, I will write new data that the host is asked to write. And then I will erase the block, the entire block later, because erasing the block, which means I just have to mark them as erased. So I don't go and frequently modify the signals in the NAND flash. So that's why erase blocks versus page. So I will erase a block. So which means whenever I do a write, what we think is I'm going to do only one write. A host write can lead to multiple writes, because I need to read all the pages. Though I'm modifying only one page, I read other pages also, and then write to another block, and then mark this as dirt. So one host write need not always lead to a one drive write. So if typically one host write leads to one drive write, that is the ideal condition to have. Most of the companies, storage companies that they manufacture, would like to have this as one, the factor as one. So this write to number of writes from the host to the number of writes to the drive is called write amplification factor. So as far as the write amplification factor is 1, if the algorithm that we maintain inside the drive, which is the firmware that we write, is smart enough that it can most of the time maintain the write amplification factor as 1, the drive performance will be better and the drive life will also be better. So I think you will be able to understand why I'm saying drive life is better, because if the write amplification factor is same, the number of times I'm going to erase and write the blocks is going to be minimal. So which means the life of the NAND flash, the drive, is going to be higher, which means my endurance of the drive will be higher. So the company, when a storage, when a big player like me, let's say a Google or an Amazon, who's buying drives from a company like a storage company like a Seagate or a Western Digital or any of those, they will look for these factors. What is that this storage company is publishing as their write amplification factor and their endurance? So the firmware algorithm, this is an R&D word once again. So we think this is just another development, right? So the firmware that we develop has to have some intelligence to see how I can keep this write amplification factor minimal. If I don't do that, there's going to be a lot of reads, more writes than the writes that host requires. And remember, when I do a write, I'm reading the pages which are not required to be modified and then writing somewhere else. And which means there are some blocks that I need to clean up. So this cleanup work is also something that the drive will have to do without the knowledge of the host or the user, right? Because when you write and if it is going to do all this, your write speed can become slow. Okay, so there will be background processes. Once again, that is an R&D word. So when to kick in a background process and do the garbage collection. Smart way of doing the garbage collection. Garbage collection is, just now we spoke about, I do a write and there are some pages that need to be modified and need to be erased. That will be erased in the background. So this is called the garbage collection, which means I am going to remove the unwanted data, in the background process. So if I don't do writes, will my drive not wear? Not really. Okay. So if you keep reading, once again, remember these are all signals. So if I keep reading, the signal value can go down. Then also it can lose the signal value, and then we need to do once again this is called read disturb. So continuous reading of the same location can make the signal value to go down. So which means a 0 can become a 1. So this also requires a background process where periodically we will go and look into such cells and modify the cells and read and write it in a different location so that the data is not lost. The last is trim. Trim is nothing but let's say if you're using a make file system, right? You want to, or rather, let me put this way: host telling the storage system or the firmware, these are the blocks to be done with the garbage collection instead of drive themselves trying to find out which are all the ones to garbage collect. I go and tell these are the blocks. So trim will say start block location and end block location, trim with zeros or trim with nothing. So I'm telling the drive that these are the blocks to be garbage collected. So I hope I gave some gist. Of course, it may be an overdump, but in SSD, signals are the way we say whether there's a 0 or 1, which means these electrical signals can fade even with write or with read. So which means that SSD's life can go down. So there are ways to keep the life longer. I forgot to talk about wear leveling. Wear leveling is once again an algorithm. And most of the storage companies, SSDs, will have some smartness in defining. If I keep writing to the same cell every time, obviously that cell will die faster. So which means I have to have an algorithm where I have to use the entire, let's say it's a 1 TB drive, all the NAND flashes and the cells I need to be using equally well, so that it's not like I'm writing to the same location again and again. And if I do that, then one of the cell goes off, then 1 TB drive will become 1 TB minus X. So in order that to not happen, this wear leveling will be done so that once again you are writing in a distributed manner so that the drive lasts longer, and your write amplification factor will also be maintained so that your one write from host does not lead to multiple writes on the drive. Okay, I think most of this I spoke here. Okay, I think I already spoke this slide, so I'm not going to talk in detail again. We spoke about one host write to an unused page will lead to reading the block and writing back, writing some pages and writing the new page. And we spoke about WAF, write amplification factor, which is nothing but one host write leads to how many writes on the drive. So we spoke about wear leveling, so evenly distributing the program erase cycle so that I'm not varying one particular cell always. This is once again an algorithm that we develop and put it in the firmware so that that I don't kill the drive sooner. Trim we spoke about, so that periodically we can clear the unused pages and then make sure that one write from host leads to typically one write on the drive. Another one is over provisioning. So typically when you buy this is especially on the enterprise SSDs, if you buy a 1 TB drive, it's not like all 1 TB will be usable. There will be, let's say, each company or each SSDs will come with different provisioning. 7% over provisioning, which means if it is 1 TB drive, it will be actually 1.2 TB. The 0.2 TB is something that is not used by the host. Rather, the drive uses that 0.2 TB for this garbage collection, or it keeps writing to the same location, then it will wear out. So it will use this additional storage space for all those activity, so that your drive size and life does not fall back. So this over provisioning, and also it will not write to the data that you are currently reading, and your access to the performance will also be higher. So over provisioning is another way to keep the WAF, right amplification factor, as far as it is 1, your performance will be better. And so these are the 3 ways where how the right amplification factor is typically maintained in the industry. Trim is a way to from the host to tell the drive that please do the garbage collection of these blocks. Over provisioning is to have some additional storage within the SSD so that will be used for all these background activities or keep the right amplification factor to 1. And where leveling is to ensure the drive is overall being used in a equal manner so that you don't kill a particular part of the drive and reduce the drive size. Any questions so far? Okay, because this is the last slide, I believe, of mine. So as I said, yeah, I've been working on validation for some time. Let me talk about some of the R&D, which is actually innovation more than R&D. So it's tightly coupled. So we spoke about data integrity. So sorry, I spoke about only R&D. Then data retention, we didn't speak about. Read disturb. Read disturb is nothing but, you keep reading the same stuff. The signal value will go down. And then there's something called data retention, which is also like if you don't power on the SSD for long, what happens is then also the cell value can go off. So the 0 can become a 1. Then also there will be an algorithm that has to be kicked in, background process, which will go and read all the bytes, all the blocks. So which means if the drive was not used for a month, let's say, then for sure this data retention will kick in. So that's why sometimes if you have an SSD based system, and if you're not switched on for a month, and if you switch on the system after a month, you might see that system is taking some time, and you might be thinking, what is happening to the system? It's because some of these background processes are running on the drive to make it work properly. So data integrity. What is data integrity? So data integrity is nothing but what I write is what is actually written. How will I check? Okay, so how do you validate that I have written some data and that is what is always written, and there is all these background process or the signal loss due to data retention or due to the read disturb or frequent writes is not actually changing my data that I've written. Right? It's very, very, very important because we are talking about applications like banking application where let's say you had $10,000 and then zero's value got lost. You'll be happy, of course, it becomes 1. But then it can also lead to a 1 to become a 0. And how do we ensure that all these background processes, all these are not really killing the data? So this is one of the key test validation that we do, because data loss is a big issue. If we have a storage media sent out and then a customer reports saying a data loss, you can imagine it will be like the entire house is on fire. So there has to be a different way of finding this and ensuring the storage media that goes out. And of course, remember the validation team is the one which is like a rubber stamp saying that, yeah, this storage device is good, it goes to the industry. So there has to be some different ways of finding the data. What is written is correct. So we were thinking of how we can do it. One of the option is, we said we will have a particular pattern. So if we can write the entire drive with some data and we read it, it's a black box. We don't know whether what we are reading is what we wrote. So we write some pattern in a particular pattern for every block or every page and rotate that. Okay, and then we write that for 1 day. Okay, so we will write the entire data in a particular pattern 1 day, and after every writes we will read. Okay, and see that whether the same pattern is coming. And after 24 hours, we will do a continuous read and to see whether any of this background process is changing my data. Okay, so this might not look like a big rocket science, but this involves a thought process and understanding of how the firmware works. Now, if I have to do this, I need to know. That's why we're talking about read disturb, right? I need to know when a read disturb can happen. How many reads to a particular cell can lead to a read disturb, right? It's not a fixed number. Or how many hours I should keep the drive idle. Let's say they say to leave the drive 1 month idle, and then if there will be a data retention that will be kicking in, then you can validate. Do you think I can wait for 1 month and then test a particular firmware and then tell after 2 weeks that it is not working? We lose 6 weeks, and which means we lose the market. So we need to find ways, we were thinking how to do this, right? So then we said, okay, we as a validation team, we also need to write some code into the firmware. So this is called instrumented firmware, instrumented firmware builds. So we write some hooks. So we will go and understand the firmware. And when is this, read disturb or data retention can kick in? So there is something called some cycles. Each of the companies has different ways of doing it. So we will have to have some hooks. So we as a validation team, because many people think validation need not know to write C code or how the firmware works. That's not the case. In R&D, validation team will also know how the firmware works. We'll have to understand the firmware, the features, and we'll also understand the firmware code, saying that when this is going to kick in. And then I will write a code there, that firmware, and I will call a function, into my Python code. Let's say I'm writing Python scripts in testing. That will be called, so that now I have a targeted way of saying, when this background process is going, I want to do this ABC test. I want to probably pump in a lot of data. I want to write a lot of data, or I want to read a lot of data.
What happened? Revati? Paramasivam?
Yes, madam.
Sir.
What's struggling
Shall we
now?
conclude?
Yeah,
Some
that's
network
what
issues may be stuck.
network issues, I hope.
Yes,
Yeah.
ma'am. Yes, I will conclude, ma'am.
Sir, we will wait for 1 or 2 minutes. Kumanan sir.
Okay, ma'am.
We'll wait for 1 or 2 minutes.
Right.
Yes. Sir?
Yes, ma'am.
Sir, Sudharsan sir has power problems. He will be joining within 30 seconds to 1 minute. He's having some problem.
Okay, madam. Participants, please be on the line. The speaker will get back to you another few seconds.
Participants, today along with the feedback form, you have to complete a quiz also. We'll post the quiz link soon. So you have to post that along with the feedback, you have to complete the quiz also.
Okay, sorry about the glitch. I think there was a temporary power break. Okay, I think where I was. Yeah. So yeah, I was talking about writing hooks and for the read disturb, for example. But then it can still, we can't wait for a read disturb to happen. The background process, let's say, it still takes a week. So then, then we said there has to be a way where the validation team can induce the, read disturb. Instead of waiting for the firmware to take its own time to, kick in the background process. So we, instead of writing a hook into the firmware, we ask the firmware to provide us a hook that we can call, with which the firmware will initiate a read disturb, like how a trim can be issued from the host to initiate a garbage collection. We said, okay, give us a way to for us to have a control on how the firmware should behave. And of course, they gave us some interfaces, and then we call that interface to initiate that read disturb so that we don't have to wait for a read disturb. So this is one example. So this is an R&D, right? So you may think, what is this big deal? And one more thing that, of course, this, we had some, I have some couple of trade secrets I cannot talk in detail that are filed because that's an IP of the company. But then this is something that is widely available. I'll talk about this. So when a new firmware comes in, taking into consideration the white box and the black box testing that we do, it takes about a week to give a confirmation that everything looks good, because we have thousands and thousands of test cases, and some of the test cases requires the entire drive to be written with some data, and then only initiate some of the test, so that we test the drive with all the data written. So this can take a lot of time, and there's as I said, a data loss reported by customer can be a very hot issue. So which means we want to make a fix and validate that quickly and give it back. And let's say the firmware found a fix within few hours, and we want to validate. We will say, I want 1 week to validate, because I don't know what changes you made. We don't know what other features that you might have broken. Though you may say, typical, I was also a developer, right? So developers thought process, I made int I equal to 0 to n to 1 to n. How is it going to change, right? That's what developers will typically say. But at the same time, I cannot take the risk, of not testing. So if I test everything, it will take a week. So then we were thinking how to overcome this challenge, because especially a hot customer issue, firmware team has found the fix in a few hours, but validation team is saying, I'll take 1 week, at least give a go. Or sometimes I might even say 1 day, at least 1 day to give you a confidence, because I need to do some right. Then there's something called code-based test management. So what this means is, we want our test to have a footprint on the code, saying that if I run this test case 1, it is going to touch the function 1, and in that function 1, these are the lines of code. These, when I run this test, that is getting traversed by the compiler, right? Or when I run this program. If I can do that, then I'll know if the firmware team says, I changed only this line X in this file. And then, and I believe they will say, okay, I believe only this much is done. But if I have intelligence in my test case, where I know which test cases, out of 1,000 test cases, let's say these 50 test cases are the ones which are touching this file, this function, to that level of data. Then what I can do is I can pick and choose only that 50 test case which can finish in 1 hour. Okay, so this is once again an innovation. Right. So you may think this is, why am I talking this? Most of us think this is not an R&D work, or this is not an innovation. So we are looking at a target, and the test cases having intelligence on the product. So the test that I run, instead of running 1,000 test cases, I am able to find which are the 50 test cases that can validate this particular code change, and quickly give a solution and give a go, which can go to the customer and put down the fire that is in the house. So with that, I want to leave some of the thoughts here that R&D doesn't mean it's always a science project or a scientific project. Innovation is important. In anything that we do, if we keep doing the same thing, it's not going to yield the results. If I'm doing something in 1 hour, I want to do it in 1 minute. That's how the customer is moving. That's how I need to develop product. I need to work on it, irrespective of what I'm developing. And customer is looking for more and more control. The last bullet is an example. So we spoke about how the drives are divided into blocks and pages, and the drive has its own algorithm on where to write, how to write. Of late, big companies, they are saying, I know how I'm writing. I know the pattern of my writes. You don't know. The storage devices manufacturers, you don't know the pattern of my writes. Let's say Amazon Web Services, right? They tell, I know how my data is being, how my drives are being used. You are developing a drive which is more, general to all the needs that is available in the market. So I want control on how data is being written more than how, where data is being written. I want to decide that, I know my writes are all sequential. I'm not writing randomly everywhere. My write patterns is not random. I particularly write files. In which case I want to have a control. So to provide that control for these kind of big players is what this new zoned namespace. Namespace is nothing but you can see that a bunch of blocks make it to a one namespace for putting this in simplicity. So zoned namespace is something new concept. I think already it's being discussed in the market, where you create zones and the end user is allowed to create zones, append zones, add zones, which means that as AWS, Amazon Web Service, I can define zones and then say I want to write to these zones. So I am able to define a better performance. With this, I'm also telling I can, now that I know how to write and where to write, the where leveling, all these are the over provisioning. Remember I told 7% over provisioning, 10% over provisioning, 20% over provisioning, whatever it is. Additionally, more space than what is required is maintained for the garbage collection and other background process. With this control provided to the customer, the amount of over provisioning can be reduced, which means for the same cost that I'm providing to the storage vendor, I'm getting more space. So these are some of the thoughts I thought I will leave there with you. With that, I will think I'm done. A second, unless I have anything more. Yeah. So with that, I'll put a closing comment. So R&D, I hope I gave a gist. R&D doesn't mean it's all science projects. I repeat, and the innovation is what we call it R&D. Any work that we do, there has to be something that has to be a new solution, new way of doing things, faster way of doing things, able to meet the end goal faster. Anything that leads to any solution or any work that we do that leads to these objectives are the ones that are being looked in the R&D. So it need not be always a new product. It need not be something completely out of this world. But if we do the same thing again and again, and if the individuals are not questioning that and coming up with new solutions, then there is no R&D. Like how I was explaining, to validate an R&D or to validate in a very quick time, we are finding a ways to build some intelligence into our test cases, where test case knows how firmware behaves. These are the kind of R&D we are expecting in the industry. So with that, I'll take a pause and I'll open up for Q&A. So back to you, whoever, Dr. Kumanan or Dr. Sonia, back to you.
So participants, any queries, please raise now. Participants. Participants, please raise your queries.
Actually, they asked us to share the PPT.
Yes, ma'am. We already informed, ma'am. We already informed. We posted it in the mail.
Okay. No queries so far.
Okay, sir. May I now request Dr. T. Kumanan, sir, to deliver the vote of thanks. Please, sir.
So, good evening to one and all. I gratitude to Mr. Sudharsan Srinivasan giving a wonderful talk about the storage management and R&D. What are the challenges and the problems in the current scenario? He explained the customer-based storage evaluation in detail and giving the examples on small talk, 5G, edge computing, and storage domain. So nowadays the storage domain and backups as a domain in IT support fields. It is an important role in any organization like a data center or any other kind of companies who giving a third party support to any bigger and smaller companies. So the Mr. Sudharsan Srinivasan is giving the more about the storage domain. I think that it will be helpful for all the 351 participants get enhanced their skill. I hope that. Okay. So once again, I thank all the participants and especially thanks to Dr. Gita ma'am, HOD Department of Computer Science, and coordinator Dr. Sonia and Mrs. Revati for continuously supporting that 5 days FDP went on well. And special thanks to Mr. Paramasivam Technical, he hosting this FDP. I request all the participants giving your feedback. It's go on the milestone of other events. It will improve our FDP in future. Thank you, one and all.
It's time to enter into our valedictory ceremony of the 1-week virtual faculty development program on emerging research trends in computing technology. May I now request Dr. Ramesh sir, JR, Events Publication Alumni, to deliver the valedictory address. Please, sir.
Yes, ma'am. So very happy. Sudharsan sir, very happy, sir. We met in our 25th year celebration.
Oh, yeah.
Yes, sir.
Nice to meet you.
Yes,
Dr.
sir.
Ramesh.
Thank you so much, sir. So this is what the connectivity with us after the program also.
Sure. I'm all the more happy. I'll be even more happy to share whatever knowledge I've gained in the industry to my institution from where I came or to any of the institution, doesn't matter.
Yes, sir. Yes, sir.
I hope it was informative. I know I probably went at a 30,000 feet level. I understand because in 1.5 hours to 2 hours, it's very tough to go deep into storage. But if there is anything, any of you want to know more, I'm open to share my email ID, whatever I shared with Dr. Gita. You guys can reach me back.
Sudharsan sir, really it's made us to think out of the box.
Sure.
Actually, your last slide is thinking out of the box. Really, it made us to think out of the box because we know little bit about storage. But you have just spoke about many things what we have to just get into storage. Really, it was a wonderful session.
Sure. Definitely. I hope it was helpful, and feel free to reach me. And if you have any questions, you can reach me on my email ID. I'll be all the more willing to help.
Thank you, sir. Thank you so much, and my best greetings to Department of Computer Science and Engineering for organizing 1-week virtual faculty development program, emerging recent trends in computing technologies. It was very happy that connecting the people together even after COVID. So this is the good time we can plan and execute so that people across the country can able to participate. And not only we will have the networking with other members also. So in this angle, I would like to appreciate the organizers and the members, committee members, department head, and all the team who contributed in such a way to execute and end the program in a very nice way with a very strong alumni. That is the foremost, very, very important. The reason is because always the alumni are very strong. And even now, the present alumni, we celebrated 25th year, and not only Sudharsan sir, and we have another connectivity with 2-3 our alumni, and we are working for some international collaboration also. So this 25th year celebration is a very fruitful outcome. Not only like a lecture, not only like a connectivity, from Canada, one university through our alumni. we are working on that. So that is a very good thing which the alumni meeting together and planning to execute all the things. Thank you all for the connectivity. I hope those who able to participate and enjoyed all the sessions and gather the knowledge which related to the advancement in the computing technologies. So this has to be move forward with some projects, move forward with some kind of actions, move forward with some kind of activities. It means that we can talk about the I request another one request to all the participants, those who are here. You can make your project. You can start your project. You can connect your project with the United Nations Sustainable Development Goal. The goal which is by the United Nations started in 2015, and it is expected to complete in 2030. So there is 17 goals. Out of 17 goals, there is some goals which is entirely connected to and the goal sheet. So the entire goal which is connecting towards the computer science engineering, you have to work with that. For example, smart cities and communities. So the students or faculty members or industry people will align your project, will align your work towards this goal. So each goal will have a targets, each goal will have indicators. So what each goal will have a target and indicators. Based on that, so this is actually, I hope you all know about this. Is the so this is what the goals. So when you search it in the net, you can able to easily find out SDG goals, and there is a starting with SDG 1 no poverty, SDG 7 affordable and clean energy, SDG 11 responsible consumption and production. In that, computer science is seriously involved. Good health and well-being, there also computer science is involved. Like that, out of 17, 12 goals where our computing engineers are very much involved in that. So I request all the participants be connected with SDG goals and take some target and work for the target. And you proudly say that you are connecting with the goals and working for that. So thanking all the participants and thanking the department for inviting me as give some essence on in the validatory function. Thank you, sir. Kumaran sir. Thank you, and Revati ma'am.
Thank you, sir. Thank you.
Thank you, sir. Thank you so much, sir. Thank you, Kumaran sir. Thank you, Ramesh sir. Now let's listen to the FDP report. It takes immense pleasure to present the report of the FDP. Department of Computer Science and Engineering, Dr. MGR Educational and Research Institute, Chennai, organizes the faculty development program from 28th November 2022 to December 2nd, 2022 through online mode. The highlight and the success of any event is the overwhelming response from the participants. We have 1,540 registration for this FDP event from various universities, colleges throughout India. The FDP was started on 28th November 2022 with Tamil Thai Valtu. The dignitaries were welcomed by the head of our department, Computer Science and Engineering, Dr. S. Geeta ma'am. The inaugural address was given by Mrs. Sangeeta Jayaprakash, Database Architect, Bose Global Software Limited, Bangalore. And the felicitation address is given by Dr. V. Cyrilraj sir, Additional Registrar. The first technical session was on the topic of research trends in artificial intelligence and machine learning. Dr. Ramesh Babu sir introduces the speaker to the gathering. And the guest speaker was Dr. S. Kavita, discussed the recent trends in artificial intelligence. She also discussed the positive and negative sides. The program was very beneficial and provided an insight on the various challenges has to overcome. On the second technical session, 2 was organized. On the second day, the technical session 2 was organized. And the guest speaker was Dr. P. Visu. And Dr. Kriba Devi introduced the speaker to the gatherings. The topic is position yourself for the success of your graduate career passion. There were exchange of ideas on the educational researchers. He also explained the various career options for the graduates and also how the faculty can guide the student to achieve the dream career. He also explained with some of the real-time examples and suggested the book names. On the third day technical session, 3 was addressed by Dr. R. Anto Orokia Roslin, and Dr. Usha introduced the speaker. The session enlightened the participants with the topic Enrichment of Design Thinking, Aspirations for Innovations. She explained various skills required to the competent in the computer industry. She also discussed in detail with all the 5 stages, various case studies were discussed and the skills required were elaborated. She also cited the examples to make the attainment of the skill. On the 4th day of the technical session, the participants were fortunate to listen to Professor G. Roslyn Nesakumari and Professor Gunasegaran introduced the speaker to the participants. The topic of the session was Emerging Trends in Machine Learning Based Image Processing. The various competencies that need to be developed and preparation required from the side of the faculty members were also discussed. In the 5th day was addressed by Mr. Sudharsan Srinivasan, and Dr. Kumanan introduced him to the gathering. And the topic of the discussion was customer-based storage evaluation and understanding. Mr. Sudarshan provided many real-time examples, and the session was very interactive and helpful to the participants. The success of any event is measured from the number of participants and the involvement. Here, I wholeheartedly thank all the participants who made this FDP a grand success. Once again, thank you everyone. May I now request Dr. S. Geeta, Head of our Department, Computer Science and Engineering, to deliver the vote of thanks. Please, ma'am.
Thank you, Revati. Good afternoon to one and all present here. Really, this 5-day session went on well. We didn't expect such a very good response we would have received from the participant side. First of all, I would like to thank our President Engineer ACS Arun Kumar, who has given an opportunity to organize this kind of a program, 5-day series, FDP series, who is always supporting us whatever we ask. He's the first person to encourage us to do something which will be useful for our faculty fraternity. Next, I would like to thank our Vice Chancellor, Dr. Geeta Lakshmi Madam, who is always expecting some new things. Things has to be executed by, especially from the Department of CSE. Really, I have to just thank her. And I would like to thank our Registrar, Dr. C.P. Palanivelu, and our Additional Registrar, Dr. B. Cyril Raj, who is the Cyril Raj. Actually, before me, he was the HOD. He's our mentor. He's always insisting us do something which will be useful for us too, because by organizing this kind of a program, we always get in touch with the people, those who are working at other university or institutions, colleges, and as well as the people from different IT industry. Thank you, sir. And I would like to thank our Joint Registrar EPA, Dr. Ramesh, who has given a valedictory address today. And he is the person mandate you have to do 6 days program, 5 days program, not a single day program. And even though we have just come up from pandemic session, but we just organized this kind of a program through online. If you are trying it in offline mode, maybe it could be as maybe the number of participants might be very less. But this online FDPs help us to have a very good number of registration as well as the benefiters. So really, we are very happy to organize this. And really, I have to thank the chief guest of the day, the very first day, Mrs. Sangeeta Jayaprakash. He was actually just talked about how to fill the gap between the academia as well as the industry. We, the teachers, are always working to fill the gap between the academia and the industry, but still there is a gap. So that we have to provide importance for that and to fill the gap of that. And our dear participants, without you, this event would not be successful. Actually, when we started to just circulate the brochures to different our friends community, we got a very good response in terms in the number of 1,500. And then coordinators, Dr. Sonia and Mrs. Revati asked me, Madam, the count is 1,500. Shall I close the registration? I told them, everybody wants to do it, but I don't know whether the time permits for them to sitting 1.5 hours, 2 hours in a weekday to listen it. Let us be open. Those are all free on those days. Let us just attend our FDP. Really, the turnout of our participants outcome is very, very good, and in the sense we didn't expect this much of one. Around 500 participants are attending through this Zoom ID, and some of them are watching through live FDPs. Really, my sincere and heartfelt thanks to all our participants who made this event as a grand success. And our this FDP coordinators, Dr. Sonia, Priyadarshini and Mrs. Revati, without them this would not be possible due to hectic academic work. They have spent their time to make this as possible. So I should congratulate them, as well as I should thank them for making this event as in a fruitful manner. Both of the coordinators, the credit goes to you. Yes, really, I'm happy to have you to organize this, and along with them, our faculty team, entire team has supported and coordinated. Likely, importantly, Dr. Ramesh Kumar, Dr. Kripa Devi, Dr. Usha, Dr. Gunasegaran, Dr. Kumanan, they are also joined with them to just host the event of every day. So my heartfelt thanks to all the senior professors of our department. And last but not least, without this person, this would not be technical. Without any technical difficulties from our side, even though it is online, something has to be happened on time. So Mr. Paramasivam made it possible without any kind of network issue, making network issues or whatever it is. He made it everything possible. So my heartfelt thanks to Paramasivam. Then if I missed anybody else, forgive me. So really, it's the end of the day, it's a teamwork. I mentioned somebody's name, but I may missed. It's the end of the day, and we have two event coordinators, Dr. Victor Sudhajaj and Mr. Praveen. Both of them are always working behind us to for the happenings of each and individual event. So with this entire team of Department of CSE, I thank everybody who are the part of this event, and thank the faculty team who have and the entire technical team who have just worked along with this to have this event a grand success. Thank you, everyone. Participants, the feedback form will be posted. I think, Sonia, this is the time to post the feedback time. Please post the feedback form. Any kind of doubt which you would like to just clarify with us, anytime you can just message them rather calling them. You message either Dr. Sonia or Dr. Mrs. Revati or me. We'll immediately just answer for your queries, and you will be getting a certificate maybe within a week. We'll try to just give the certificate within a week. Thank you for your patient listening for the past 5 days and made this event as a grand success. This coordinators, if I missed anybody else, please you can join with me. You can.
No, ma'am, you said everything, ma'am. You said all the numbers. Ma'am, quiz also is there. So I request all the participants to post the online quiz as well as the feedback link is posted. I request all the participants to raise for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मागे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you all. Thank you for your wonderful support for the past 5 days. Thank you all.
Thank you, ma'am.
Thank you, ma'am.
Recording stopped.
The recording has stopped.
Thank you. So I request all the participants to post the feedback as well as online quizzes there. Kindly post it. Thank you. Sonia ma'am.
Yes, ma'am.
Ma'am, anything you want to say?
Feedback and